Hey everyone, buckle up, because today we're diving deep into a wild new theory of gravity.
Oh, yeah, this one's a doozy.
Instead of gravity pulling everything together, this theory says it's actually...
A push.
Exactly. We're exploring a book called Gravity and Creation, the Grand Febernachy SMF RVS Theory.
And don't forget that awesome YouTube video from Atlantean astrology that breaks it down.
Right, so get this. This isn't just some dry physics paper.
No way.
It goes full on into theology and philosophy too.
It really makes you rethink our whole place in the universe.
It totally does. So, this Grand Febernachy framework, or GF for short, what's the basic idea?
So picture this. Instead of massive objects pulling things inward, the vacuum of space itself is pushing things outward.
Hold on, I always thought the vacuum of space was, like, empty.
Yeah, that's what we usually think.
So how can empty space exert a force?
That's where it gets really interesting. According to GF, the vacuum isn't truly empty.
Huh.
It's this dynamic field they call the relative vacuum of space, or RVS. Yeah. Imagine it like a constantly shifting landscape with peaks and valleys.
Okay, I can kind of picture that.
Yeah, and this RVS interacts with what they call subtle magnetic fields, or SMF.
Okay, break that down for me. What are these subtle magnetic fields?
Basically, think of SMF as like a higher dimensional form of magnetism.
Higher dimensional
And
magnetism.
here's the wild part. The faster something spins, the stronger its SMF becomes.
Wow. And the book's author connects this SMF to the concept of light from the Book of Genesis.
Right. He even describes it as the consciousness of God.
That's a pretty profound connection. So you're saying this SMF, this divine light, comes from outside our usual dimensions and influences, like the movement of everything in the universe.
That's the core idea, yeah. And the book even suggests that magnetism itself might originate from beyond our usual understanding of space-time.
Whoa.
It's wild, and this RVS is constantly responding to this SMF and the rotation of stars and galaxies, creating this outward push.
So instead of mass pulling things in, it's this constant interplay between SMF and RVS, pushing things apart.
You got it.
That's a huge shift.
Mm.
So what would this mean for things like neutron stars?
Oh, neutron stars are a great example. We usually think of them as these super dense remnants of collapsed stars, right?
Right.
But according to GF, they're not actually super dense at all.
Really?
Yeah, they're held stable by this outward push from the RVS
Wow.
and their strong magnetic fields. They're thought to be a result of this constant influx of SMF driven by their crazy fast rotation.
So no collapsing cores or unimaginable densities.
Nope. Not according to GF, anyway.
That's wild. What about pulsars? You know, those spinning neutron stars that emit those beams of radiation.
Ah, pulsars. The GF theory sees them as like cosmic beacons whose pulses are a result of this interplay between SMF and RVS.
Okay, so they're super precise timing.
It's not just because they're spinning super fast.
It's because of this dance between these fields.
Exactly. It's a totally different way of looking at them.
So we've got neutron stars and pulsars reimagined. What about supernovae? You know, those massive explosions when stars die?
Ah, supernovae. Yeah, instead of a catastrophic core collapse, GF suggests they're more like carefully choreographed events.
Very correct.
Yeah, so as the star spins faster, its SMF intensifies, and the RVS kind of guides its outer layers outward.
So instead of a violent explosion, it's more of a graceful process.
It's more like a cosmic ballet, resulting in those beautiful nebulae we see.
That's a beautiful way to put it. What about some of the bigger mysteries, like how galaxies rotate? Does GF have anything to say about dark matter?
Oh, absolutely. GF suggests that we might not even need dark matter halos to explain why galaxies spin the way they do.
Oh, interesting.
The vacuum push from the RVS intensifies at galactic distances, providing the extra oomph to keep stars from flying off.
So no more invisible matter, just this cosmic push.
Exactly. And that's not all.
What else?
What about the fact that the universe is expanding at an accelerating rate? GF tackles dark energy too. Instead of invoking dark energy, GF proposes that the very structure of the vacuum itself.
You mean the RVS?
Yeah, the fractal nature of the RVS gently pushes galaxies apart, leading to the acceleration we observe.
Hold on, did you say a fractal vacuum? I'm picturing a jagged, constantly changing landscape, but in the vacuum of space.
Yeah, that's a great way to visualize it. It's not just smooth, empty space. This fractal structure allows the push from the RVS to vary across different scales, influencing everything from tiny atoms to vast galaxies.
So it affects everything.
Everything.
This is truly mind-blowing. And it doesn't stop there, right? What about black holes?
Black holes. Oh, yeah. GF offers a drastically different perspective on those two.
How so?
Instead of being infinitely dense singularities, as predicted by Einstein's theory,
Right.
GF suggests that black holes are actually stable vacuum objects.
Stable.
Yeah, they're prevented from collapsing further by the outward push of the RVS. They have incredibly strong magnetic fields because of intense SMF, but no infinite density or breakdown of physics.
So no singularity.
Not in this theory.
This is incredible.
Yeah.
So we've got gravity as a push instead of a pull, a dynamic vacuum shaping the cosmos, and even this potential connection to the divine. Where do we even go from here?
Well, we've only just scratched the surface. In the next part of our deep dive, we're going to delve even further into the implications of the grand Febernachy theory.
Exploring what it could mean for our understanding of the universe.
And our place within it.
Can't wait. This is already so much to think about. I bet you're out there thinking the same thing, right?
I bet they are.
Stay tuned, because we're just getting started.
Oh yeah, the best is yet to come.
All right, so we've laid out this radical concept of gravity.
Yeah, gravity is a push, right?
Driven by this interplay of
SMF and RVS.
It's a lot to wrap your head around, for sure.
Definitely.
But what's really exciting is that this grand Fibonacci theory...
It's not just some philosophical thought experiment, right?
Exactly. It actually makes predictions that we can test.
It does. The book and the YouTube video both highlight several areas where future observations could really make or break the GF framework.
Like what? What kind of things?
Well, for example, the theory predicts these specific patterns in the large-scale structure of the universe, like how galaxies and galaxy clusters are distributed.
So we're talking about actually seeing the effects of this fractal vacuum push, but on a cosmic scale.
Exactly.
That's incredible. What kind of observations could help us confirm that?
Well, there are some next-generation telescopes coming online soon, like the Vera Rubin Observatory and the Euclid mission.
I've heard of those.
They're going to give us a much clearer picture of the universe's structure.
So if GF is right...
we should see a different distribution of matter than what we'd expect if dark matter halos were the dominant factor.
So we might actually be able to see evidence of this cosmic push playing out on a grand scale.
We might.
That's amazing. Are there any other ways to test this theory?
Oh, yeah, absolutely. Remember how we talked about the cosmic microwave background radiation?
The afterglow of the Big Bang.
Exactly. Well, GF predicts that this fractal vacuum push would have left a specific imprint on the CMB.
An imprint.
Yeah. Something we could potentially detect with more advanced satellites.
So we could be looking for echoes of this cosmic push in the very earliest light of the universe.
That's the idea.
That's mind-boggling.
Yeah.
What about black holes? We talked about how if they're not these infinitely dense singularities like we thought, how can we even test that?
Well, that's where gravitational waves come in.
Ah.
When black holes collide, they release these ripples in space-time that we can now detect, right?
Right.
Well, the GF theory predicts that the gravitational waves from merging black holes would have slightly different characteristics.
Different how?
If they are, in fact, these stable vacuum objects rather than infinitely dense points.
So the way black holes ring after merging.
It could tell us whether they have those super dense cores or not.
It's getting into some really intricate physics here.
It is, but that's the beauty of it, right?
What do you mean?
The GF theory isn't just a cool idea.
It's a testable hypothesis.
It is. Future observations will either add weight to the theory or lead us in a different direction.
Either way, it's pushing us to think differently.
And to ask new questions.
That's what makes science so exciting.
Absolutely. It's this constant back and forth between ideas and observations.
It's not about being right or wrong.
It's about getting closer to a deeper understanding of the universe.
I love that. So let's say for a moment that this GF theory is proven correct. What would that mean for our understanding of the universe and our place in it?
Wow. Well, if the vacuum of space is this dynamic, responsive field that GF suggests, it means that our universe is far more interconnected and alive than we ever imagined.
It's like the universe itself is a living, breathing entity.
Constantly evolving and changing.
And if this push-based principle is fundamental to how everything works, could that have implications for our understanding of energy?
Oh, it could be revolutionary.
In what way?
If the vacuum isn't just empty space, but a source of immense energy and potential, maybe one day we could learn to tap into that power.
Whoa.
Sounds like science fiction, I know.
It does.
But who knows? The possibilities are pretty incredible.
Imagine the possibilities. Interstellar travel, unlimited clean energy.
It's mind-blowing.
But even beyond the technological implications, this theory really makes you rethink our place in the cosmos.
It does, yeah. If this subtle magnetic field, this SMF, is a manifestation of a higher consciousness, like the book suggests,
Yeah.
then it points to a deeper meaning and purpose to the universe.
And our existence within it.
Absolutely. We're not just random specks of dust, you know?
We're part of something much grander.
And more interconnected than we ever imagined.
It's a humbling and inspiring thought.
Mm-hmm.
But even if future observations don't fully support the GF theory,
The questions it raises are still incredibly valuable.
they are. It challenges us to re-examine our assumptions about the universe.
And to explore new possibilities.
It reminds us that there's still so much we don't know.
And that our current understanding is just a snapshot in time.
This has been an incredible journey so far. What are your thoughts? Are you as captivated by this grand Febernachy theory as I am?
Oh, absolutely. I'm hooked.
I'm already eager to see what the future holds for it.
Me too.
Will it stand up to scrutiny? Will it revolutionize our understanding of the cosmos?
Only time will tell.
And that's the exciting part. The conversation has just begun. This theory has opened up a whole new way of looking at the universe.
I have a feeling we'll be talking about it, debating it, and testing it for years to come.
You know, we started this deep dive talking about a new theory of gravity.
We did.
But it's already taken us so much further than that. We've discussed black holes, dark matter, dark energy, the nature of the vacuum, even the potential for new technologies.
It really highlights how interconnected all of these concepts are.
It does.
That's the power of a truly innovative idea, you know? It doesn't just answer old questions.
It sparks new ones.
Pushing us to explore uncharted territory and to consider possibilities we might never have imagined before.
Before we wrap up this part of our deep dive, I want to touch on something that's been lingering in my mind throughout this discussion.
Oh yeah, what is it?
We've talked a lot about the science behind the grand Febernachy theory.
I have.
But what really struck me is the connection it makes between science and spirituality.
It's fascinating, isn't it?
It is. The idea that the SMF, this force that shapes the universe, could be linked to the light of creation.
A manifestation of a higher consciousness.
It definitely blurs the lines between scientific inquiry and spiritual exploration.
It does.
And even if you're not particularly religious, the idea that magnetism itself might originate from beyond our conventional understanding of space-time,
Right.
it's incredibly thought-provoking.
It is. It challenges our very understanding of reality.
And opens up the possibility of a deeper connection between the physical world and something beyond it.
Yeah.
Makes you wonder, right? Are there other forces out there? Other dimensions, other realities? Things we just can't even perceive yet.
It is humbling, yeah. We think we have things figured out and then...
A theory like this comes along.
And totally shakes everything up.
Exactly. It reminds you that there's still so much mystery out there, so much left to discover.
And that's what makes this grand Febernachy theory so exciting.
It really is.
Yeah.
So where do we go from here? What's next for this theory?
Well, the most important thing is to keep testing its predictions.
Right, like we talked about earlier.
Those upcoming observations from telescopes, gravitational wave detectors.
They could provide crucial evidence.
Yeah, to support or refute the theory.
We need to see if, the distribution of matter in the universe
The patterns in the cosmic microwave background radiation.
and the characteristics of black hole mergers,
Exactly. We need to see if those actually match up with what the GF theory predicts.
and even if some of the predictions don't pan out.
The theory has already started a really valuable conversation.
It has.
It's challenged assumptions about gravity, the vacuum of space.
Even the nature of reality itself.
It's definitely gotten us thinking outside the box.
That's what's so important. We need these bold, unconventional ideas to push the boundaries of science.
Absolutely. The grand Febernachy theory might not be the final answer,
But it's a step in the right direction.
forcing us to look at the universe with fresh eyes, to question what we think we know.
And to embrace the mystery.
Exactly.
So what do you think? Does this theory have the potential to revolutionize our understanding of the cosmos? Or is it just a fascinating thought experiment?
Only time will tell, right? But one thing's for sure.
That
This theory has captured our imaginations and sparked a conversation that'll keep going long after we're done here.
I think so too. And that's what we hope for, right?
What's
To
that?
inspire that curiosity, to encourage that critical thinking,
Keep the exploration of the universe alive.
thriving.
Exactly.
We want you all to walk away from this with a sense of wonder.
A thirst for knowledge.
And maybe even a few new questions of your own.
Oh, yeah.
If this grand Febernachy theory has taught us anything,
It's that the universe is full of surprises.
it is. So keep exploring, keep questioning, and never stop looking up at the stars.
With that sense of awe and wonder.
Because who knows what incredible discoveries are waiting for us, just beyond the horizon of our current understanding.
The journey of discovery is never truly over, you know. There's always something new to learn, something new to explore.
Always something new to amaze us.
That's the beauty of science, the beauty of the universe.
Until next time, keep those minds open, those imaginations firing.
We'll catch you on the next deep dive.